Okay, guys, so today we're gonna learn about scientific notation, or we can say it as a standard form. So scientific notation and standard form are actually same, so they share the same idea. So you are doing the standardized number here. Before we start our lesson, before we start the counting, I want to give you about the importance of this standard form or scientific notation. So as you can imagine, in science, in scientific world, we have so many numbers that can be expressed in a very, very big number. For example, the length or the distance between sun and earth, for example. So the distance between earth to moon, earth to sun, and so on. We have so many types. So this is for only example. About the distance, can you imagine how long or how many kilometers the distance from Earth to Moon? Is it 100 kilometer? No, it is way bigger than what you can think, right? So as the fact is about from Earth to Moon is about 300, for example, 300 million meter round to nearest one significant figures. It's not an exact number, of course. And while Earth to Sun is way bigger than this, much bigger. Okay, so this big amount of zeros has to be simplified, right? So if you put the zero like this, it will be so much number and it's not so efficient for you. Now we go for the small part. So if the biggest part is already known here, it's about the distance astronomical number. So there might be a smaller number also about the size of red blood cells. It's too small, so we can simplify or we can guess about the number 0.00000 something. Let's say 000. Okay, I give a random number, 5 meter. Again, we know that a large number and a small number share the same difficulties on writing the zero, right? So the zero is quite large and too small and too much. Both of them are too much. So we need to find a standardized form in order to express these numbers as simple as possible. Okay. So we try to simplify, actually, not to make more complicated, but we try to simplify the numbers by using the scientific notation. Okay. That's what the purpose of our learning today. Any questions so far? Okay. What's the purpose? Simplify by using a power. Okay. To make the large number and small number more simple to be written. Okay. You can write the simple number from this. So scientific notation is simplification of number. So you simplify. Make it more easy to write, easy to read, and easy to be understood. Okay, I'll put this in our note later. You can access anytime. By the way, the size of red blood cells is not accurately like this. It might be way smaller, but I just want to give you the expressions of how small it is and how complicated it is if you put zero at every time of writing the numbers. Okay, so it's very useful in your scientific understanding and money also about the trillion rupiah, billions, and so on. Too much zero, and we can simplify it here. So let's start how or the technical way to convert. Now, let's imagine a number, 35 billion. Okay, so we want to simplify the number into a scientific notation or what we call as a standard form. Okay, In UK, in Cambridge, we use standard form and scientific notation as an equal definition, same definition. So if you want to do this, you have to imagine this number has the maximum of one place value. So this is the first thing that you need to understand. Maximum is one place value. Okay, everyone pay attention, please. Okay, maximum one place value. So we have so many place value here. 1, 10, 100,000, 10,000, 100,000. What is it? Million, 10 million, 100 million, billion, 10 billion. And we want to simplify to maximum 1 for the place value. Therefore, you need to look at this number as 3.5. Okay, that's the first step. Not done yet, of course. So the first step, we put this as one place value. So 3.5, not 35. Be careful. Why it is not 35? If it is 35, the maximum place value is 10, right? Doesn't make sense. You need to follow the order, follow the rules. The rules is always one place value. So unit place value or one place value or integer place value. So 3.5. Then this is how we simply do this. From 3.5, you want to reach the last zero. Let's see. So 3.5 is here. How many steps does it take to go to the last zero? 1, 2, 3. It has to be right in between the number. 4, 5, 6, 7, 8, 9, 10. Then we have 10 steps. Second step, multiply by 10 power 10 steps. So this will be the answer. So second step, you find the amount of steps. All good? Okay. 10 to the right. So you put 10 on this part. Another number. I'll give you another number so we try to focus and have more variations of the question. Let's say I have number 3, another way, another number, 7890000. Okay. So how do you convert this into a standard form? Step 1, you find the maximum one place value. What is it? 7, right? So 7.89, not 78.9, not 789. So 7 point. It has to be 1 for the maximum place value. Cannot be more. Cannot be 10. Cannot be like this. This is wrong. And then this is wrong. So wrong because 100. So you put here as always. Maximum of one place value. Then you go the decimal. So start from 7.89. 1 to the right, 2, 3, 4, 5, 6 steps, right? So 6 steps to the right. Therefore, you need to put times 10 to the power of 6. That's it. Understand? That's for understanding the big number. How about understanding the small number? Let's see here. In order to understand the small number or to solve the small number, it will be the same, but different in the steps. The big number, you go the decimal to the right. Okay. For the small number, you go the decimal to the left. Let me show you what it means. Let's say I have 0.00000008. For example, the size of the bacteria and so on. Okay. Or microseconds, something like that later, yeah. How do you solve this? Again, put the number in maximum one place value. What's the number? 8 only. Okay. Now, the decimal of 8 is always on the right side of 8. You go the decimal to the left. Okay, left, right down. How many times? 1, 2, in between the number. 3, 4, 5, 6, 7, 8. Luckily, it's saying 8. So you multiply by 10 power negative 8. So what is the conclusion then? If you go left, the power has to be negative. That's right. If you go right, the power is positive. Very good. So if you go left, the power is negative. Okay, one more example. 0.00001234. Okay, it's more complicated. Focus on the first thing. First thing first. Maximum one place value here. 1.234. Cannot be 12.34. Cannot be even 0.1234. That's wrong. Okay, 1.234. And then you multiply by 10. Reserve the number first, and you only focus on the power. 1.234 is located here, right? How many decimal place you have to move? 1, 2, 3, 4, 5. Negative 5. So 5 left. This is 8 left. 8 to the left. 8 to the left. 5 to the left. All good? Understand so far? And actually, these 2 pages, I have 1 here and 2 here, is finished on explaining all these 11, what do you call, 11 slides. Now, after we convert the number, a normal number, which is called, we call an ordinary number, to standard form, now we try to focus on the standard form to ordinary number. So this is ordinary number. Ordinary means with so much zero. Ordinary number to scientific notation, or standard form, same. Now we're gonna go for the next part. We flip the working from standard form or scientific notation to ordinary number with the same idea. I give you an example. Now we try to convert the standard form to ordinary number. Let's say I have 3.28 times 10 power 7. Okay. Now, how do you convert this into an ordinary number? Write down 328 here, right? If it is 7, so how many decimal place you have to move? 7, left or right? Right. Why? Positive. Okay. So move this decimal, the previous decimal to the right by 7 times. 1, 2, 3, 4, 5, 6, 7. Stop here. Therefore, all the empty spaces put 0 right in the curve. This is the curve, right? In between the curve. That's the answer. Or this is not so good to be seen. Simplify or make it more proper. 3280000. So this will be the ordinary number from standard form. Standard form to ordinary. Understand, guys? Simple, right? Now, next. 0.03. Oh no, wait. Let's say 4 times 10 power 8. How do you do? Write down 4. This is the decimal. This is the easiest way. You put 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's it. Or if you want to do the step, you can do it. 1, 2, 3, 4, 5, 6, 7, 8. So how do you read that number, guys? 400 million, right? Just make a bit distance between 0, group of 3, and you can get the number easily. Okay, how about One more. 1.35 times 10 power, no more, not negative yet, 4. Okay, 1.35 times 10 power 4. It's the same thing. You move the decimal 4 times to the right. So 1, 3, 5. Start here. Okay, always start from the point. 1, 2, 3, 4. Only 2 extra zeros. Then to simplify, 13,500. How about if it is negative? Okay, if positive right, negative left. That's the keywords. Another number, I will make it equal 3.28 times 10 power. I just change the power, become negative 7. So this is more a bit complicated because you move the decimal to the left. So I have to put the number a bit to the right to compensate the position of 0 later. Yeah. Okay, guys, listen. Negative 7. So 7 left. 7 to the left. Okay. Start from point this. 1, 2, 3, 4, 5, 6, 7. The decimal belongs here. Okay. Now the other number is 0, 0, 0. Right in below the curve, not here. Don't put on the top. You put the X on the tray, right? And then the first number is always 0. That's the extra number. Has to be put. Then 0.000000328. This is for the proper writing. Don't stop here. Okay. Do not stop here. Why? It's very messy. Yeah, too messy to be shown. Now, one more, guys. 132. This is not a scientific notation, neither an ordinary number. 5. So if I have 132 only, where is the point, guys? No, here, right? If you don't have any point, if this is the point, okay, you stop here, go left by 5 times. But if you don't have any point here, so this is 132 regularly. You put here, right? At the end of the decimal, at the end of the unit place value. Go left by 5. Start from here. 1, 2, 3, 4, 5. The decimal put here. And then you put an extra 0 on in between the numbers, in between the point. So 0.00132. That's it. Do you understand, guys? All of you? I want to make sure that this easy part has to be understood by all students. How about the others? You sure? Okay. So actually, we finished this whole period topic and we still have about 10 minutes. Let's see the question. Later. Okay, now focus on the screen right now. And when you use the scientific notation, there are 2 kinds of exponent, positive and negative. We learned it previously, right? Positive exponent for going right, negative exponent for the small number. Positive is for the big number, negative is for the small number. This is positive exponent. Look at the 8. So you move the decimal 8 to the right. Negative exponent, you move the decimal 7 to the left. Okay, in this case. Keep focus, guys. Keep focus. Before our snack time. When changing scientific notation to standard notation, this is wrong, guys. When changing scientific notation to ordinary number, because standard notation and ordinary number are actually equal. Scientific notation and standard form is equal to ordinary number. Ordinary number. We use the IGCSE and Cambridge definition. Okay, wait, display, duplicate. A moment, guys. So everything here is on all times. Let's see, guys. With a positive exponent, move the decimal to the right. If 4.08 times 10 power 3, so the decimal go right by how many times? 3 times. 1, 2, 3. And the decimal moves There you go. That's the animation. So nice. There you go. That's all. So 4080. Don't forget to fill in your zeros. Okay? Fill in your zero. One only. No problem. Now, when changing a scientific notation to ordinary number, the exponent tells you to move the decimal. With a negative exponent, move the decimal to the left. Still remember what I teach you previously? Go the decimal to the left. 1, 2, 3. And then you move the decimal there. Okay, it's moving right now. And put the 0 on the left side also. There you go. Okay. Now, an easy way to remember, exponent positive going right, negative going right. Going left, sorry. Positive going right, negative going left. The exponent tells you how many times, how many steps, right? 3 steps. Okay, going right by 3 steps. There you go. Here, going left by 3 steps because it's negative. Okay, it's the same. Now, try changing this number from scientific notation to ordinary number. Still wrong. Okay, it's not updated yet. They use the American standard, but we use the Cambridge standard, which is UK. In UK, scientific notation and standard notation are the same. Okay. Now you can do it in your notebook. Yep. But can you just guess the number here, guys? How many zeros you have to add extra? 1. Right? Because 1, 2, 3 is already taken by 6, 7, 8, and then 0. Right? No need to write in your notebook. Just follow along. You move the decimal to the left by 3 times. There you go. Okay, you can imagine the number. If you cannot imagine, you write the number. If it is 7, okay. 1, 2, 3, 4, 5, 6, 7. Oh, it's even not reaching the 0, right? 1, 2, 3, 4, 5, 6, 7. So the number has to be 851390455.67. No more. No extra 0. Okay. Negative 5. Okay, you have to put it in below. Look at this. Put to the left by 5 times. 1, 2, 3, 4, 5. The decimal here. 1, 2, 3, 4, 5. 0.4 zeros, 409,748. There you go. Okay. It's the same. All good, guys? Easy, right? Now, when changing from ordinary number to scientific notation, so you cross this, ordinary number to scientific notation, so move until it reach 1 place value, right? Remember? So 3.258. What's your guess? Times 10 power? 3 steps, right? And go left. Negative 3, that's right. Be careful, no problem. If you do the mistake at the first learning, it's very, very acceptable, but don't do the same mistake on exam and worksheet. Okay, 10 power negative 3. The base is always 10. If you ask why, because we are learning the digits of 10 integers, right? 10 base 10. 0 until 9 is 10. Negative 3. Huh? Wait. I'm sorry, guys. I'm sorry. When changing from ordinary number to scientific notation, this is 3,000 something, right? So you put the first place value. I just mix up with just now. So I will re-explain. You put this to the 1 place value, right? And you go 1, 2, 3, right? Make sense? All good, guys? Power 3, yeah? Not negative 3. I'm sorry. Okay. When changing the ordinary number to scientific notation, here, 3,48943. I don't write it. I don't read it properly. So what you need to solve is actually as easy as this. You put 3.48943. You just ignore this. And then you go the decimal to the right. 1, 2, 3, 4, 5 times 10 power 5 going right. All good? Next. If the number is less than 1, it will be negative. For example, this. So 6. You put 6.72, go left 1, 2, 3, 4, 5, 6, 7, 8. Go left, negative 8. Now, what has to be focused on? What have to be written? You need to write it neatly. If you don't write it neatly, you will mess up your zeros later. And put the details. The details matters a lot. How? Okay, let's go, guys. 9.872432. You go how many places to the right? 1, 2, 3, 4, 5. Oh, so fast. 6. Cool. How about this? 3.45. You go left. 1, 2, 3, 4, 5. Therefore, negative 5. 5 times. Okay. So put the detail. You need a glasses if you cannot see well. Okay, 8.376. 8.376. Go left 1, 2. Oh, easy. Negative 2. Right? This is 5.673. Go right. 1, 2, 3. Go right. 10 power 3. 3 steps. That's it. And we finish. Okay. Now on the next topic, we're gonna learn about the other way.